So if we move over on into the schematic overview of Blueprint, that's the whole thing. So similar to the simplified schematic we had, this whole picture. Take a bit of a look at that here in the thing itself. Get this. So again, on the left we got C++ because everything is based on that, everything in Blueprint. There's a number of core C++ mixed Blueprint features here. So basically the transition from stuff, stuff that holds up C++ or both of them, or that's in between the two, or that helps transition it over. We'll cover these in detail. But there's that in between. There's some data features. So for example, curves or assets that both C++ and Blueprint can read from. And we're going to take a look at the core features. So this is the core of Blueprint. This is extra, debugging, everywhere where Blueprint is used. And Blueprint to Blueprint communication is a topic in itself. Okay. Let's start off with C++. And the beginning, the blue box. So again, it's inheritance-based, as just mentioned in the intro. So there is a given. That's a core part of the functionality. And then you have the events, functions, or variables as core building blocks in Blueprint. They can be made in Blueprint, but the majority of them come from C++. In fact, I believe, if I remember correctly, I have a slide here. Let me double check that. So that's all the code that we need to essentially in C++ define a new Blueprint function or variable. So it's very, very easy to extend, I would say.
Yes.
It's really built to make the seamless integration between C++, Blueprint, not two different systems. It's all one same thing.
Yeah. Just one specifier can create a new node from a function and a new variable visible from Blueprint.
Yeah.
So.
And again, the inheritance thing, here's a graph that kind of symbolizes that. You got actor at the top as, there's a pawn. There's a wheeled vehicle or vehicles. That would be a class we made, but this is part of the framework. The fact there is a pawn and wheeled vehicles. You would then extend it with perhaps a class of your own, or vehicles, or cars. Then there's a Blueprint class underneath that then again builds on C++. Then there's another Blueprint class that builds on the previous one. That's called down. So it's very inheritance-based. There are function libraries. Could be done in Blueprint as well, but in C++ too, you can write these functions in C++ and then expose them to any Blueprint across the project, right? So
usually are static functions that you can do. You want not to be attached to any kind of actor or object. So general functions that do general things, and you can expose them to Blueprint and can be used easily.
So it's another way that C++ can help and extend and empower Blueprint as a language. So there's that framework. Again, this was covered in the programming class, but it's all here as well. Because, for example, just a simple act of building a character, and I'm not sure if you got the simplified version here left. I think we deleted that. But if you were to do a new project, right? I'm not going to go through with it all the way, to not restart this one. But if you were to, for example, do a first-person Blueprint project based on a template, what it's going to do is going to generate you a simple Blueprint with the bare minimum to have a first-person character, but it's going to be based on a C++ class. And again, framework is there. So essentially, you can get a first-person game up and running with almost no functionality, exactly because all the underlying code and functionality, everything is already there. From input to what else we have, the movement component to the game modes and replication, everything. That's kind of what's been sketched here too, but it's just a summary of maybe the most important classes.
Yeah.
And that's a really key part of the Unreal Engine, that wealth of functionality that exists by default that you base it on. But that's essentially it, because then we're going to end up at Blueprint itself. Now, before we go there, as mentioned, there are optional data features, has been shown in the programming class as well. It's the same ones over here. Blueprint can also use them. Data tables, assets, and curves as reference in programming. But Blueprint itself. Now, we're going to move over to the upper box first, because this is the core of Blueprint as I see it. There's three obvious parts to Blueprint, because you'll see them the moment you open Blueprint as you open it. So if you see, if I switch to the editor, and you open any one Blueprint, it doesn't really matter which one. Let's get rid of this. I'm going to take the character perhaps. You got event graph, construction script, viewport. There's three tabs. And there's components over here and some other things, but those 3 tabs are kind of the core, I would say. So the viewport speaks for itself. It's the viewport, it's just a visual representation of essentially the components that make up the blueprint, because the blueprint is also kind of like a prefab. It's just a number of components grouped together in one thing. The event graph is where most of your work will be, pretty much everything, essentially. This is what executes during runtime. So all the things that it can do. This is the actual scripting itself of the game. For example, here we can see, on begin play, when the thing enters the world, we're going to create a UMG, a user interface widget. We're going to add it to the player screen. So here we script all the functionality. And there's a construction script, which in this case is empty. I can find one that is perhaps not empty. For example, I got a blueprint spline that was shown in the world building class. That one will have a simple construction script. Construction script is just a script executed as a preparation script, I guess, before play. So you can use it to prepare things with. And those 3 are the core parts. So 2 of them are visual scripting. One of them, the viewport, has a component. It's just a bunch of components that speaks for itself. There's more than 40, 50 or so different components you can use. Now, the event graph has got a number of things in there in turn. Basically, construction script as well, but because event graph is the main one, I'm going to primarily refer to that one, but it's the same thing. It's got variables, functions, macros, and event dispatches. So the functions are whatever you can do. It's in general, anything you want. The print string, for example, let's do hello world. That's a function. On begin play, we have hello world. Right? It's very simple. You've got those. You've got variables. So you can here, for example, you have a variable. It's a float. We get it. You can create variables. It speaks for itself. You got functions and you got macros. They're essentially fairly similar to an extent, at least in obvious functionality point of view. They group nodes together, to put it simple, in a reusable block. I'm trying to remember where we made one here, I think. There we are. Although that one is empty. Try to remember where did we make
function.
Function. You remember?
No.
No. Okay. Let's try to find the example function. Otherwise, we'll just make one. For example, here we got in the minion. So here we got the enemy. We have a function called try hit, and basically it groups these nodes together in a function called try hit. So now we can just drag the function in, and we got the whole thing. Macro works more or less the same way. There's some technical differences beneath the hood.
Yeah.
The macro is essentially copy pasted, put it bluntly.
It's just replacing all those nodes.
Yeah. Whereas a function is instance, I believe. Yeah. So you have that, and you have the event dispatcher. Sorry, event dispatcher is slightly less commonly used, perhaps. I believe, if I remember right, that the button at the door over here has an event dispatcher. So I'm going to look at that one. So we got an event dispatcher over here. It's one of the many ways we're going to later on get to blueprint-to-blueprint communication, but this is part of blueprint-to-blueprint communication. That is the event dispatcher called button trigger. It's a way of sending the signal from one blueprint to the next, or sending out a message that, hi, I'm being triggered. If anyone wants to do something with that information, feel free. It dispatches the event. So that's the core. There's 2 additional things that are, especially obviously replication is very major. Let's start with timeline first. It's more limited. Seeing that in world building too, but the timeline is an embedded sub-editor into Blueprint that allows you to animate curves, or true curves rather. For example, over here, that is a timeline. So one that plays, double click it, you see this is going to play that curve, it's going to output that, and then, for example, you can set the location based on how the curve lerps between these 2 positions. Okay, that's what I typically use it for. But you can use for any kind of in-blueprint animation, fading, anything like that. G-replication is built in through. If I remember correctly, I believe we've made an example over here. So the example game we have is not multiplayer-based, but it does, just to line up what it would do, we've placed all these relevant nodes here that shows some of the blueprint replication stuff. You have a switch for has authority, you can do process, you have that server-only icon, for example. If you've got a variable, you can say that this is replicated at the moment, as also shown by that icon. So the important message here is that Blueprint is covered all the way through. It has replication built in, and it's multiplayer ready. You can build a multiplayer game, a very basic one, within minutes with pure Blueprint.
Yep, as the rest of the engine.
as anything else in the engine, as C++ as well. So that's the really key part, that all of that is right there. So that is the core. Then there's a number of additional things. So things that you don't necessarily are going to use, but that you can use. Things that are additional. So going back to the graph at the bottom here, this blue box, we've got something called child actors. Essentially, it's one actor in another actor, one blueprint inside another blueprint. Typically a blueprint, but doesn't have to be, but one thing in another. They're meant for specific use. They're not meant to be part of the core architecture. So preferably don't build your entire game based on the ability to have child actors. But one particular use, what we have here, we got these enemies, right? And the idea is that when the enemy sees the player, we need to somehow have a marker above it that says, I'm the active enemy, or I have like a banner above the head of the enemy. That banner is a little setup, right? It's a little effect, it's some particles, maybe sound, some functionality, maybe it's rotating. So the best way forward with embedding something like that in many different classes, because we might have many different enemies and they all have to have the same piece of functionality. That's a good example of a child actor. I believe it might be this one. Oh, there we are, see? So you made this little setup over here with this marker that says, I'm angry, I'm attacking. It's a self-contained thing. And the minion can then, and it does this during scripting, but I'm going to manually do it by hand now. It's the same thing. It would have a child actor in there, and in the child actor we can then say class child, which I mistyped, child actor example, and what we get now is that, right? And that's the real idea with a child actor. It embeds one blueprint in the other and extends the functionality further. Again, not meant to be part of the core architecture, but interesting. We have blueprint components, and when we say blueprint components, we don't mean regular components, we mean very specifically the components you can make through blueprint that hold blueprint. That's a weird explanation, but roughly in that direction. Yeah. When you create a blueprint, so we'll do a new blueprint here, new blueprint class, you got actor component, scene component. So we're talking about these two. They allow you to define a component yourself through Blueprint. So you see, this is the list of components. You can extend that with your own version, made in Blueprint in turn, and put certain functionality in there. I'm trying to remember what we had there as an example. I think in the player character, I think I did something, right? Something? No, not sure. Let's see. Yeah, so I made a scene component here. So that's exactly that. Scene component is, increase the size of that a bit. There's nothing in here, essentially. You can see there's no viewport, but there's a function in here. Example function says just hello. If I were to add that to scene component example, I can have that component in the blueprint of the playable character, and then I can call on I think it was called example function in component, that one. If I double click that, I actually go here. See, so now I can access pieces of functionality within the component that's then shared between actors or blueprints. So it's one of the things you can do. Again, not meant to be something you do continuously. It's just an optional thing, I would say. There are function libraries and macro libraries. They're the same thing that C++ offers. It's just a function or a macro, but not defined in a single blueprint, but rather in a neutral asset and then accessible by every other blueprint in the project, which we've also made, if I remember, again, what we call that. So there's a macro library. There's a macro example, again, similar. You can see there's one thing here called count how many monsters in level, meaning I can now go to any other blueprint, right-click, count how many monsters in level, macro, and I get that thing. Yeah, same thing. Beyond that, there is another layer underneath this. There is the editor blueprint scripting. By the old name, it's called Blutility, so you might see that name float by, but that's the old system. But editor blueprint scripting. So you use Blueprint to extend the editor. There's 3 different ways you can do that. You can do it through editor utility widgets, so with the user interface, or you can do an action utility or an editor utility object. An action utility means you can right-click and see the script, An editor utility object means that it runs in the background automatically whenever the engine does something. I've got 3 basic examples of that I'll briefly cover. This is a relatively new feature, at least in its current shape. And it's really amazing to see what you can do with it. So let me see if I can find back the widget. See which one was which. Sorry, there's a folder called utilities, so I guess that one. And for example, here's a basic one. It's just using UMG. So the standard user interface editor you use for building in-game UI. Just for the sake of example, I've made a simple button here that says open the level tools panel to show that you can open panels between them. And as you then run that, so I'm going to say run that, an actual panel, I click that, I get a different panel. I made some tools, it's just experiment a bit and get a feeling for what this can do. So I made different things to get a feel for it again. Show in log, show modified asset. But this is done, as you see here, just with normal UMG. If you look in the graph, it's got blueprint under it. This is the scripting for the tool. So you can script your own tools. And the actions do the same thing. If you, for example, were to right-click on a mesh, I got asset scripted actions. These are the things I've defined myself in Blueprint Editor scripting. So these things here are things, one of these, asset actions and actor actions. That stuff I have over there. See, these are the different things. And that's really cool. For example, I tried looking at how do I build a basic validation plugin, like you got an approval process for assets that come in. So all of that can be done over here. And likewise for the editor utility objects, you have to define it in, if I remember correctly, the config file, I can't remember which one, I think engine or one of those. And then it will run automatically in the background. So for example, you can say on import of a static mesh, when you import a model, automatically run the script and have the script check if the mesh has these and these and these things as part of the import to validate it. So that's one thing you can do. That's all optional. And then we're getting towards the part of the engine that uses Blueprint, and then after that, some performance and debugging. So before we go to the purple box here, which is where it's used by the engine, just to mention here, Blueprint needs to be compiled, but it compiles very, very quickly. It typically compiles within seconds, especially with the right setup in the project. It's not meant to take much longer than that. There is the ability to nativize blueprints, which means that during the cooking process, it's going to convert the blueprints to C++ code. It's not really what I probably would advise for larger productions. It's something you can play with and experiment with and see what happens, but in general, I would say
it's meant for a small chunks of blueprint,
yes.
Like very small things that that they are like looping over a great amount of actors, that kind of things, not for the whole functionality of a project.
No. Yeah. So, but nonetheless, it exists. Eventually, once the blueprint has been compiled, it's going to run through a VM, a virtual machine. It compiles the bytecode, run through the virtual machine. It runs quite fast. There's a lot to say about blueprint performance, but it is actually pretty fast. It doesn't beat C++, obviously, but it's definitely not. Performance is definitely not a concern most of the cases. But we're going to end up here at parts of the engine using BP. So a point I've made before, but Blueprint is totally integrated across the engine. So to understand Blueprint is really vital if you're going to work with different tools in the engine. It's not just about scripting, it's just true. So just to go over how integral this is to the engine, you got the normal actor blueprints. That is what you've seen me do a couple of minutes ago. It's just, it's an actor, it's an asset in the content browser. It's based on actor or some actor class, and it has blueprint in it. So there's that. That's the normal one. Then you got the level blueprint. So every level has a level blueprint in it, which is a script essentially you can use for specific things for that level only. So a puzzle, for example, is going to be specific to that level probably, checkpoints, anything like that.
Yep. Anything that has a hard reference to any actor in the level should be placed there.
Yeah, or is unique to it, and it wouldn't make sense to put it in a separate class because it just belongs to it, right? And every level, if you got sub-levels, every one of these levels has another blueprint in it again, so literally every level. Then, in fact, the animation blueprints, are animation blueprints, as the name implies, and has blueprint in there. Help me remember which was the...
You can go to blueprints.
Yeah, to the character, I guess.
Yeah. Go to the character, skeletal mesh, component, double click, and on the right top, blueprint, animation blueprint.
Right. So this thing, which is, by the way, to make it clear, it's an asset over here. You can see this is the asset that we have open. It's part of the animation system. This is blueprinting, you see, all of it, both the event graph and this. So it's used here too. Sequencer for cinematics is using blueprints, although not by default. I mean, it's not obvious by default, but it's there. And it's a feature that's perhaps lesser well known, but it's nonetheless really cool as well. Everything's really cool. So,
no, of course.
Yes. So open level sequence, within here, you're able to define, and I have to actually remember where as well. You see, I have a blueprint within sequencer. So if you add an event to the track, the event itself becomes an embedded blueprint where you can do things. For example, I can make the minion angry at that point in cinematic. UMG, the interface editor, as seen when we covered editor scripting, it's all blueprint as well to script the interface. Niagara, I don't have an example of this one, but the new particle editor, you can extend the functionality of the particles with visual scripting, which is blueprint. And then the variance manager has blueprint as embedded rules. So it's really, really spread through the whole engine. So here we have a variance manager set. You can see I'm going to do this. I can see this, and I can say I want to have a function caller here. And the function caller, I can create a binding on add actor component. It has blueprint in it. So there's a lot there. So again, it's vital to understand blueprint. And then we're going to end up at blueprint to blueprint communication and debugging. There's a lot to say about blueprint communication. This is where things get a bit complicated to do in the small amount of time we have. But to give a brief recap on the different ways you can handle communication between blueprint, and then you have to understand that is a complicated subject, and there's various pros and cons for yes, which one to use and when to use which one. But I'm just going to sketch what's here and bring up the idea that there are all kinds of considerations to be had here. Okay. So one blueprint needs to be able to talk to another blueprint, and it can do this with direct references. Easy one. It's very simple, very straightforward. It can simply say in one blueprint, for example, I have the door, the button rather. This button needs to activate that door. I can then say, here's a property that's called door actor, and I can say that door should be this door, direct reference. It's very simple as well in the script itself. We simply make a variable that is that specific type, BP level doors, and we make sure it's public and definable in the properties. That's it, direct reference. There is a way of doing casting, because at times you might not be able to have a direct reference to it, which means you might not, the variable that makes up the thing you're trying to talk to might be undefined. It might be something. But if it's something, then Blueprint can't give you a specific function to access in there, or variable. So if we got the button...
Try to cast the character, for example.
That's okay. I want to get to the button because the door actor has something in it called open door, right? That's the function. In fact, this is the door blueprint. Again, it's not a good door, it's just a wall, but it's a door, trust me. In there is a function called open door. I can cast to it if I have, for example, any actor I have. So I'm going to make a variable. I'm going to call this just based on actor object reference. And then this one is undefined, it's just actor. So I would first have to cast it to level door, and only then would I be able to access open door. So it's a cast in between. So there's that.
So if there's success, it will call that function, and if not, it will do nothing.
Yeah, in this case, it will do nothing, yeah. Then we've got interfaces. It's a bit more advanced, a bit more hidden, but it allows the same thing, communication between blueprints, but without a direct reference. To an extent, there is still some degree of reference between them. So you would create an interface somewhere, I have an interface here somewhere. So here's an example interface. There's an update HUD via the player. That's it. There's nothing else in here. There's just that one function, and there's nothing even in the function. You can see where this is referenced. So it's referenced by, for example, the player. Now look at the player, and see if we find where we've got this, which is the endless question, isn't it? Sometimes a challenge to find back where different things have been used. Otherwise, we can just.
The important thing of interfaces is that you can cast any function in an interface on every actor, and you just try to call it. And if that actor doesn't implement that interface, that blueprint doesn't implement that interface, it will fail. But if it does implement that interface, it will cast that function.
Yeah, actually here we got one. That's an interface. So we don't, look, there's two different ways of doing this. This one is the same update enemy count as this one, but a different circle round to the target. This one needs to have the player pawn, but then it has to cast it in order to access the HUD component to update a function in there. This is with interfaces, it just needs the player pawn, but it's undefined what it is, so there's no reference. So this is a lot of the reasons, a lot of complicated reasons underlying it. It's about referencing, it's about memory in turn, about loading in turn, but interfaces are the more powerful version for communicating between things. You could, of course, just route everything to C++. That works as well. There are cases, for example, here where we have that. I believe one of them is called, and I can go to any blueprint, so I just went back to the button here. Enemies, something's called get number of enemies.
Yep.
So that's a variable that doesn't exist in this blueprint. It's just like a global variable that was defined in C++. It's actually defined in one of the other classes. I've got which one, but one of the other classes has this as a variable, but
yes,
it bridges to C++. Anywhere else can retrieve that variable via C++ without a direct reference to that class. So that's nice. And it works for functions and events as well.
That function is in the blueprint function library.
Yeah. So that's another way. And then you have the event dispatcher that has been briefly shown earlier, as used by this button as well. So when you overlap with the button, call button triggered, which is that event dispatcher. And in the level blueprint, it would then, in this case, close that entirely to free up a bit of space. In the level blueprint, it would, and in fact, I'm thinking it's in the game blueprint. So I'm going to click and open the level blueprint on that one. It can then see off the level floor button is triggered, and it continues. So this is that event dispatcher continuing its path, and it runs the additional scripting. Works especially well, I think, for level blueprints, as we're doing here. Okay, so those are different ways to communicate. Again, there's more complicated reasons why you want to pick one over the other behind it, but that's the set of ways of doing that. Okay. And in terms of performance and debugging, there's a few things here too. Some of these we've seen in other classes, so we're going to leave them be. So front end has already been covered in the engine structure class, so we'll leave that be. The stats have already been covered in programming and world building. One important one here is probably stat game, which shows the actual blueprint time. If anything, it is by far the most important as far as blueprint is concerned. So if you do stat game, then you're going to get blueprint time if you were to run the game. That's because I just changed something in the blueprint while showing an example. But it says blueprint time, the third item at the top, it says 0.31 milliseconds average for the blueprint time. So it shows you the cost of the blueprints running, which is an important one to take into account. And also the tick time related to that. But then there's more specific features that are really about blueprint itself, in particular all of this more or less. Automated testing we can immediately move on from. We've shown this, or at least touched on it, in the engine structure as well. It's for running automated tests. It can be run on blueprints too. It's primarily a C++ thing, but it does support also automated testing on blueprints. It would require a rather specific naming convention for a level and so forth, but it will run. But let's focus on these 4 to wrap up this schematic into Blueprint. So there's a Blueprint debugger and the logic visualizer. You're going to see both of them at the same time. In fact, the Blueprint watcher will probably come up as well. So any Blueprint that you have, if you have the Blueprint open while the game is running, and we look at the Blueprint, maximize that for a second. Over here, we've got no debug object select. I can now select a player, so it recognizes what's in the world that is similar to this one, and we can see it execute as it's running. In fact, we can even see the variables. So you can see the logic flow through the script as the game is executing, which is really, really helpful to see that visualized. And you can also right-click things and do watch value. And you see the values instantly displayed, so you really get an idea of what it's doing, what it's thinking, and so on. As part of that, in turn, you can also set a debug, breakpoint. So you can right-click anything, add a breakpoint. You can then step through. Right, you can go through that and understand what it's doing, where it's going, step by step. As part of the Blueprint watching variables goes, there is also an interface, by the way, in I'm trying to remember where now, where it would group all those watched variables together. I always keep forgetting where to. Do you remember where? I think it's in
Visual Logger, no?
No, there's a Blueprint tool, I think. Blueprint debugger. Okay. And then there's a watcher. So you have a list there too, and there's some additional tools also here for Blueprint debugging. There's a call stack execution flow as it's happening. So that's there as well. And lesser well known, there is a visual logger, which is fun to use. So in Blueprint, you can define things to be logged to the visual logger. I think I've done a few of them here. I didn't connect them. But for example, here there's a note called enable vislog recording, enable it for the player, record the location, or record some text, record variables, record whatever you want. You can print it and have it be tracked by the visual logger. Again, this is disconnected, but the enemies do have it enabled by default. I actually think the by default AI components automatically report into the vislog, I think.
Okay.
I believe. Because, and you will be able to see how that works, if I open up developer tools visual logger somewhere and we run the game, I'm going to press start on this thing, you see it automatically finds 2 enemies that are in the level. I'll try to get to the enemies so we see what they're doing. Oh, there's one behind me. One there, another one there. I'm going to stop that, stop this. And what we've got now is got a visual representation of where those enemies were, including what they can see, other information that is tracking. You get a lot of stuff here, path following, AI control. You can see all the info as it's rolling, and you can see it over time as it goes through. So that's a really nice little feature to follow Blueprints over time.